Welcome to MAID 103 Educational Statistics under Professor Dr. Maris Lasco. We are the Group 2 reporters, namely Ma'am Amy E. Sabilino, Ma'am Christine S. Calonia, Ma'am Glenn S. Rosello, and yours truly, Lavina C. Codo. We are the team himself. The desired learning outcomes in this video are to understand what is correlation in statistics, to identify the different types of direction of correlation, to identify the different types of correlation, tools for determining data relationships, how to manually calculate correlation coefficient, how to calculate correlation coefficient using Person in Microsoft Excel, and how to calculate correlation coefficient p-value in Microsoft Excel. What is correlation? Correlation refers to the statistical relationship between two entities. In other words, it's how two variables move in relation to one another. Correlation can be used for various data sets. It's a common tool for describing simple relationship without making a statement about cause and effect. Direction of correlation. The scattered plot explains the correlation between the two attributes or variable. It represents how closely the two variables are connected. There can be three such situations to see the relationship between the two variables. Number one is the positive correlation. A positive correlation would be 1. This means the two variables move either up or down in the same direction together. The second one, here are some examples of positive correlations. The more time you spend on the project, the more effort you'll have to put in. The more money you make, the more taxes you will owe. The nicer you are to employees, the more they'll respect you. The more education you receive, the smarter you'll be. And the more overtime you work, the more money you'll earn. And then number two is the negative correlation. A negative correlation is negative 1. This means the two variables move in opposite directions. Here are examples of negative correlations. The more payments you make on a loan, the less money you'll owe. As the number of your employees decreases, the more job positions you'll have open. The more you work in the office, the less time you'll spend at home. The more employees you hire, the fewer funds you'll have. The more time you spend on the project, the less time you'll have. And number three, zero or no correlation. A correlation of zero means there is no relationship between the two variables. In other words, as one variable moves one way, the other moved in another unrelated direction. Here are some examples of entities with zero correlation. The nicer you treat your employees, the higher their pay will be. The smarter you are, the later you'll arrive at work. The wealthier you are, the happier you'll be. The earlier you arrive at work, your need for more supplies increases. The more funds you invest in your business, the more employees will leave work early. Here are the different types of correlation tools for determining data relationships. Number one is the person correlation. The person correlation coefficient, or R, is the most common way of measuring a linear correlation. It is a number between -1 and +1 that measures the strength and direction of the relationship between two variables. When one variable changes, the other variables change in the same direction. Next is the Spearman correlation. Spearman's rank correlation coefficient is a technique which can be used to summarize the strength and direction, negative or positive, of a relationship between two variables. The result will always be between 1 and -1. The last one is the Kendall correlation. Kendall rank correlation, nonparametric, is an alternative to Pearson's correlation. When the data you're working with has failed one or more assumption of the test, this is also the best alternative to Spearman correlation, nonparametric, when your sample size is small and has many tied ranks.
Good day, everyone. My name is Amy B. Sabilino. Today, I will discuss to you how to calculate the correlation coefficient. How to calculate the correlation coefficient. You can use the formula below to calculate correlation coefficient. Steps to calculate correlation coefficient. First, determine your data sets. Second, calculate the mean of the x and y variables. Third, subtract the mean. Fourth, multiply and find the sum. Fifth, take the square root. And sixth, divide. This is our data sets. Okay, this is the table containing the columns of x, y, the product of xy, x squared, and y squared. For x, we have the numbers 1, 2, 3, 4, 5, and 6. And for y, we have 2, 4, 7, 9, 12, and 14. Next is the product of x and y. So 1 times 2 is equal to 2. 2 times 4 is equal to 8. 3 times 7 is equal to 21. 4 times 9 is equal to 36. 5 times 12 is equal to 60. 6 times 14 is 84. Moving on to the next column, x squared. So 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, 5 squared is 25, and 6 squared is 36. For y squared, we will also square the values of y column. So 2 squared is 4, 4 squared is 16, 7 squared is 49, 9 squared is 81, 12 squared is 144, and 14 squared is 196. Next step is to sum up each column. We will make the sum of x values so the sum is 21. Now we will determine the sum of y values. 2 plus 4 plus 7 plus 9 plus 12 plus 14. That give us the sum of 48. Okay, next is the sum of the product of x and y. 2 plus 8 plus 21 plus 36 plus 60 plus 84 is equal to 211. Now the sum of x squared values. 1 plus 4 plus 9 plus 16 plus 25 plus 36 is equal to 91. And then the sum of y squared. 4 plus 16 plus 49 plus 81 plus 144 plus 96 is equal to 490. Okay, so this is the sum of x values. Next, this is the sum of y values, which is 48. This 211 is the sum of the x, y values. Okay, 91 is the sum of the x squared values, and next is the sum of y squared. So now that we have the sum of all the columns, we will use now the formula in finding the numbers. Okay, n is the value. Okay, n is the values that we have in the x column. Okay, for example, 6. Okay, our n now is 6. 6 times 211 minus 21 times 48, divided by the square root of 6 times 91 minus 21 squared times 6 times 490 minus 48 squared. So 6 times 211 is equal to 1266 minus 21 times 48 is 1008, or 1266 minus 1008 divided by the square root of 546 minus 441 times 2940 minus 2304 is equal to 258 divided by the square root of 105 times 636. Okay, now R is equal to 258 divided by the square root of 66,780 is equal to 0.998. So the R value is equal to 0.998. This indicates that there is a strong linear relationship of the x and y values, or there is a direct relation of x and y. If x increases, the y is also increases. Okay, and that's all about how to calculate the correlation coefficient between the two variables.
Good day everyone, my name is Glenn S. Roselo from Group 2 of Team Himsum. So today, in this video, we will take a look on how to calculate a correlation in a Microsoft Excel in Pearson's R. Now on your screen, here we have two variables hours studied, and that indicates the number of hours studied for an exam. And then exam grade, which is just a percentage grade on an exam. Now we want to calculate the correlation between these two variables to see if there's a relationship there. So note that person R correlation measures the degree of linear relationship between two variables. So back then, we want to go data and then select data analysis. And here we want to select the correlation. Then click OK. And then for input range, what we want to do is select all of our values, and I'm going to go ahead and select the variable names as well. So click the mouse and hold the mouse bottom down and select all the cells there. And I want to be sure, since I did not select the variable names or labels, that I check on the labels in the first row box, then click OK. And then here I am going to go ahead and expand this a little bit because it's quite small. And then we'll go and round this down as well. Okay, so that's our correlation. I can also put it right here. It's the same thing. So let's take a look at what this is here. So the correlation between exam and our study is 0.86. R is equal to 86. Now, the indicates are very strong positive correlation between number of hours and studied the grade on the exam. So, in other words, the way we would interpret a positive correlation is people who studied more hours tended to do better on exam. Those who studied fewer hours tended to do worse on the exam. Now, the correlation ship isn't perfect, but it is very strong in this example.
At this juncture, we are going to learn how to calculate a correlation and p-value in Microsoft Excel. We already have calculation and correlation, but we didn't have the significance value to see whether it was statistically significant or not, because the correlation procedure in Excel does not have the p-value. So to calculate the correlation coefficient and statistical significance, we have to go to the data and then data analysis, select for regression, click OK. And there are two boxes here, the input Y range and the input X range. For the input Y range, we have to select this one, the exam grade. And then for the input X range, then select the hours studied. Let's not forget to include the variable names. Then select labels, click OK. And now we already have our summary of output. Okay. In using regression with two variables, the multiple R is identical or the same with the person's result, which is R is equal to 0.86. And if we notice, the significance F and the p-value is the same, are the same. And now we are going to use the alpha that is equal to 0.05. And it is in the rule that if the significance F or the p-value is less than 0.05, then there is a significant value in correlation. Since our significance F and p-value is 0.00 0.001, which is less than 0.05, then we can say that there is a statistical significance. So the correlation coefficient of 0.86 is, is statistically significant. So the correlation is significant. Since the correlation coefficient 0.86 is statistically significant, then there is a significant positive relationship between the variables hours studied and the exam grade. Therefore, there is a significant positive relationship between the number of hours spent studying and the grade on the exam. Correlation is equals to 0.86 and a p-value is less than 0.001. That's
That's
all
all
for
for
our
our
topic
topic
about
about
correlation,
correlation.
how you're going to calculate manually and using the Microsoft Excel. Thank you and mabuhay.